Very good morning. This is Prem Kumar, Assistant Professor, Department of Computer Science. So today I am going to talk about a topic called and a subject cryptography. Under that cryptography, I am going to tell you about how the encryption and decryption is going to take place. So before I enter into this topic, I want to tell you about what is meant by cryptography. So when you talk about the cryptography is nothing but they are going to send the data in a secured manner between the sender and the user, sender and the receiver through the networks. So how are we going to secure the data means by applying certain algorithms like an encryption process as well as the decryption process. So when I was doing the encryption process, my exact data it is going to be transformed in the form of a ciphertext, so which is like an unscribbled word. That if in case any unauthorized access is trying to access the data, it was in an unreadable format. So they cannot be able to easily understood what the data is going to be transmitted from the sender as well as the receiver. That is what exactly we are going to see it in the case of the cryptography. The key components that we are going to see in this case of the cryptography is one is the plain text, the ciphertext, and the encryption and the decryption. So when you talk about the plain text, what is the plain text is? That is nothing but the original message what exactly the user is going to transmit to the receiver. So the second one is the ciphertext. So after you encrypt your data, the data will be in the form of an unstructured manner. So unstructured manner means it was like an unreadable format of the data. We call it as a ciphertext. So the next one we say is an encryption. The encryption is nothing but, so your plain text is going to be taken by an algorithm. That algorithm is going to do some encryption process. The result of the encryption is called as an encrypted text. So the next one is nothing but the last process. So when the data, the encrypted data has reached the destination site, the receiver who is going to receive, who receives the data, they are going to decrypt the data by using the same algorithm with the help of certain keys. So that is what we have in the case of cryptography. So the plain text, that is nothing but your message, original message, and the ciphertext is nothing but which is going to give you a meaningless data of your plain text. And the next one is the encryption. The encryption is nothing but an algorithm which is going to convert your plain text to a ciphertext process. And the last one, the receivers is going to receive the reverse process of your encrypted process is called your decryption process, right? Then the next one, what are the basic components? What are the basic components we are going to have in the case of cryptography is the main part we have to see it in the case that is the keys. So the key is plays a vital role in the case of encryption as well as the decryption. So there are two types of key concepts we have in the case of cryptography. One is symmetric key and the other one is asymmetric key. When you talk about a symmetric key, what are the exact thing we are saying under that is, so the same key is being used for both encryption as well as the decryption. So there will be a two set of keys. If in case I am going to use a set of key means the same set of key is being used by the receiver also. That is what, if I use a public key, the receiver is also use the same set of public key. If suppose I am going to use some other key, the same key is being used to the receiver also. So that is what we are saying, the same key is being used for both encryption as well as the decryption. That is we are going to see it in the case of symmetric key concept. The example algorithm which is working under the symmetric key are, one is the AES, we call it as an advanced encryption standard, and the other one we can say another important algorithm that is DES, that is data encryption standard. So this is the part of your symmetric key concepts. Not only this, there are several algorithms. I just listed an example which we can familiar to this symmetric key concept. The next one is the asymmetric key. In the case of asymmetric key, what is the process it is going to use is, there will be a known public key crypto system. We call it as a known public key crypto system where the two different keys is going to be used. One is the public key and the other one is the private key. So the public key will be shared if suppose I am going for an encryption with a public key from the sender side, the receiver is going to use a secret key for the decryption process. So for encryption there will be a separate key, and decryption there will be a separate key. This process is called as an asymmetric key. So we cannot use the same key for both encryption as well as the decryption. That is what we are going to see in the case of asymmetric key concept. Okay, so both key concept is rightly talking about the secure of your data. That is integrity. It is going to maintain the integrity, and it is going to give you the confidentiality of your data, and it was reliable to the data, and unauthorized users cannot able to access it when it was traveling, or when the data has been traveling in between the networks. That is the role. So that is the main concept we have in the case of the key. And the next one, the algorithmic, cryptographic algorithms. What are the cryptographic algorithms we have here? That is, one is, we call it as a block cipher. What is the block cipher? Here the data is going to be a fixed block size. Your data is going to be in a fixed block size. For example, some certain algorithm is going to convert, or they are going to take the data as 64 bits data as a plain text, or certain algorithm is going to take 128 bits of data. That 64 as well as the 128 is in the form of a fixed block size. That is what we are saying. It is in the fixed block size. Either it should be an example like 128 bits or 64 bits of data is going to be taken in as a plain text, and this is going to be converted as a cipher text. That is what we are going to see in the case of the block cipher. Then the next one is the stream cipher. When you talk about the stream cipher, here we are going to encrypt the data in the form of a continuous streaming process. We are going to take, first I am going to take a portion of the data, and after it has been converted, the next portion of the data is going to be taken, and likewise we are going to take the data in a continuous pattern in the either in the form of one bit at a time, or it may be a byte at a time. So it may be a 1 bit at a time, or it may be a 1 byte at a time. So likewise we are going to take the data as a continuous format, and like for example, when you take an example for this process is more efficient for streaming the data like videos or an audio format. This is what we are talking about, the stream cipher. And the next one is hashing function. This is also plays a vital role in the case of cryptographic concept. That is, the cryptographic functions that takes an input or a message that returns the data in the form of a fixed size. It is going to give you the data in a fixed size of string of a characters. It is going to give you a fixed size. When you apply your hash function, it takes certain inputs or a message as a plain text, and it is being taken to the function, and it will give you the result as, or it is going to return you the result as a group of characters as well as the strings. So that is what it is going to do, and the primary use of this algorithm is the hash function algorithm is it is going to ensure your data integrity. It will not make any changes in between the data when it was traveling through the network. And the next one is the digital signature. When you talk about the digital signature, it is used to verify the message when it was more authenticated format. It is going to provide an authenticate, and that too in the case of digital signature. See, the digital signature is a combination of hash function as well as the asymmetric key format. See, so there are two techniques which have been applied in the case of digital signature: combination of hash function and also the asymmetric encryption format. When you are applying these both, the data gets more integrity. That is what we are saying. It is in a digital signature process. Okay, so it is providing the proof of the senders as well as an identity to ensuring the data security. So all the encryption algorithm, decryption algorithm is going to talk about only this process. That is, it is going to give you the identity to ensure the data integrity. And the next one, the types of cryptographic attacks. What are the types of cryptographic attacks we have here is, one is the brute force attacks, and the next one is cryptanalytics, and the third one the man in the middle attack, and the replay attacks. When you take a brute force attacks, what happens here it is, so the intruders, the unauthorized person who is trying to give all set of combinations, that is, he used to try all the possible keys to decrypt your data. That is, we call it as a brute force attack. Then the second one is we have as a cryptanalytics. When you talk about a cryptanalytics, cryptanalysis, what it is, they are going to find out what is the weakness we have it in that encryption as well as the decryption algorithm. It is going to tell you what is the weakest part of the algorithm, so that we can easily go and interrupt the algorithm, and they can disturb the algorithms like taking the ciphertext, and they can easily decrypt by knowing the weakness of the algorithm. That is called as a cryptanalysis role. And the next one is the man in the middle attack. The man in the middle attack, his role is who is going to intercept in between the users, like senders and the receiver. A man attackers intercepts the communication between the two parties So the sender and the receiver will be there, and there will be a third person who will intercept your data, whatever it has been exchanged between the sender and the receiver. So that is, we say it is a man in the middle attack. And the last fourth cryptographic technique what I here mentioned is that is replay attack. What is that replay attack is? See, so intercepting and retransmitting the information. So the previous one we have discussed, the man in the middle attack. There will be a third person who is monitoring the data between exchange the sender as well as the receiver. But in the case of replay attack is the person who is third person who is monitoring, intercepting the data, who receives the data and he used to replay data to the receiver. Okay, that is what we are intercepting and retransmitting the valid data to gain the unauthorized access. We are trying to access the data without knowingly the senders as well as the receivers. That is what we say it is a replay attack. And the next the thing what we are going to see here is the cryptographic practices. What are the cryptographic practices we have is, the cryptographic is an essential in modern technology, that is modern digital technology. It is underpins the security of the financial transactions, online communications as well as the cloud storage and more also. The most recent advanced technologies has been used in these kinds of cryptographic practices. So some of the examples what I have mentioned here, it is one is for the secure communication. Securing communication example for that is the browsers what we are using in our systems. That is HTTPS is a hypertext transfer protocol. S denotes as securing. An additional part we have added into the case of the secure communication. The next one is data storage encryption. The data whatever we are storing in the cloud as well as any places, the data is going to store the data in the form of an encrypted file. So if anybody is trying to access the data, they cannot able to get the exact meaning of what it is. Okay, that is what the storage is. The data storage encryption. The next one, digital signature. When you talk about the digital signature, it is already we have seen it is an authenticated process. We are going to provide the authentication of the authenticity of the data by using this digital signature. And the next one, the password management, very well known, very much familiar in the case of password protection. So before giving the password, we will be giving some username, and after that we have to proceed with the password. If the password does not mismatch, if the password is not matched with the database what we have already created, it will not allow the users to enter into the block or enter into the state or any other application. So that is, we say it is a password management, that is encrypted storage password. And the next one is not only for the logging process, it is also for protecting the data. So if suppose if you are trying to access a particular data, it required a password. If you are giving a valid password, it allows you as to access the file, otherwise it will not access you the file. That is the thing we also say it in the case of password manager. And the next one is the blockchain and the cryptocurrencies. So these are all the places where we are seeing the cryptographic in practices. And the next one, we are going to see a very much familiar algorithm that is called the DES, that is data encryption standard. So we know, as I told you, that encryption standard, encryption is nothing but we are going to take the plain text and converting the plain text into a ciphertext, and that ciphertext is going to be transmitted throughout the network. Once the ciphertext is received, the receiver is going to decrypt the data using the same set of an algorithm. So in this DES data encryption standards, so it is going to do certain process. We'll see how it is going to work. So when you take this data encryption standard, as I told you that it is a symmetric key based encryption algorithm where it was adopted by the National Institute of Standards and Technology (NIST) in the year 1977. Okay, and it was a federal standard for the encryption in the United States, and it's become one of the most popular encryption algorithm in the world of several databases. Okay, and then the DES was found to be vulnerable to a brute force based attacks due to the relativity, short key length as well as, and it's since been supersedes by more securing algorithms. We'll see how this data encryption works. So this is one type of an algorithm, and also another version of this is called, we say it is an AES, that is Advanced Encryption Standard. Well, I'm going to talk about only about the DES. So what the key features what we have here in this, one is the block cipher. It is going to take bits of data or a byte of data at a time. That is what it is going to see. It operates on a fixed size. In the case of data encryption standard, it is going to take the data as a 64 bits of data. That 64 bit of data is a pixel size. Okay, this 64 bits is going to be divided into two halves. That is what we are going to see it in the next case. How it is going to be divided into two part, and what about the key features? What are the keys you are going to use it in this algorithm? We are going to see it. If the data is encrypted as larger than 64 bits, the algorithm proceeds the data into the multiple blocks. So suppose your data size is 512 bits. What happens is I am going to divide that 512 bits into 4 128 bits. Okay, so this is what I am going to divide. So my data size, the algorithm is going to accept only the data size of a time at the time is 128 bits or 64 bits. If the 64 bits means I am going to divide that 64 512 bits into 8 bits. 8 times I am going to divide the blocks as 64 64 64 and 8. In that pattern I am going to divide it. The next one, see, this is how I am going to see. My encryption standard is going to work like I am going to take the 64 bits of plain text, and this plain text is going to be sent with a first level of permutation choices, that is initial permutations. What actually it is going to take, what it is going to do is, what are the 64 bits of data I am taking for the first level, that data is going to be within, in between the data, the position is going to be interchanged by using the initial permutations. After that, I am going to set it into these several rounds. I will tell you what is going to happen in the case of each and every round. So when I go for the first round, that is first here, usually the algorithm takes the input as a plain text as well as along with the key, and that is going to be decrypted and give you a set of ciphertext. Okay, that ciphertext is going to be sent to the receiver, that they are going to decrypt by using the same algorithm. But in the case of here, we are going to follow up to 15 rounds for the encryption. Okay, so the first round, whatever the permuted results I have taken it from the plain text, that is going to be sent to the round 1. So before I go for the first set of encryption, what I need is I need a key. In the case of data encryption standard, I am going to take what is the size of the data I am taking for the plain text size, the same size I am going to take it as a key size. But here each and every round is going to take, every round is going to take the block size is going to be only the 64 bits. But here it is going to be somewhat different. It takes the 64 bits of your key and it is going to be a permuted choice. It is going to convert that into 56 bits, and that 56 bits is going to be again second level of permutation choice has been applied to the key, and which will give you the size of 48 bits. This final 48 bits of keys alone is being sent to a first level of round for the as a key. And like whatever the results we are getting in the first round number 1, that will be sent to the second round for the encryption, and same process is going to be followed. Like it is going to take the 64 bits, 56 bits as left circular choices, and that is going to be sent to the second level of permutation choice, and that key is going to be sent to round 2. So likewise, it is going to go for 16 rounds from round 1 to round 16. So 15 rounds it is going to perform. After the 15th round, whatever the results we are getting now, that result is going to be again we are going for a reverse initial permutation. So here first, after the very first thing what we have done is we have did a initial permutation, and at the end of the 15th round, the results whatever we have now, we will be having a swapping between the portion of the left side is going to be exchanged to the 64 bits of the data is going to be divided into two halves. One is the left 32 bits and the right 32 bits. The left 32 bits is going to be swapped to the right side, and the right 32 bit of the data is going to be swapped to the left side. So interchange is being takes place between the data, and that data is going to be initially permuted again. Inverse initial permutation has been applied, and the final result will be called here it as a ciphertext. This is what we are saying it is in a ciphertext. So all these rounds is going to do several methods, going to follow the same methods for encrypting the data, but every rounds the data as well as the keys gets differs, and it has been applied all the 15 rounds, and at the end of the 15 rounds we will be again go for any swapping the data, and swapped data is being converted as an initial inverse initial permutation. That result will be called as a final ciphertext of the data. This is only the data is going to transmitted through the networks. Okay, and at the end of the receiver, and what they are going to do is they are going to do the reverse process of the decryption process. Okay, so I am going to tell you about in detail about how your data is going to be processed. So the data whatever we are sending as in a 64-bit is, that 64 data bits is going to be divided into two halves. That is, the first 32-bit we call as in the left half, and the second 32-bit we call as in the right half. This right side and the left side data is going to be interchanged. Before that, see, it has been, see, your left shift is going to apply, and the left shift of your second half is going to be done, and the first 32-bit, the second 32-bit. The first 32-bit is going to be applied with the left shift, and the second 32-bit we call it as what we are calling it as a right half, right? The data left 32-bit is a left half and the right half. Left half is also being sent for a left circulation, and right data is also go for a left circulation. After the circulation, we are going to go for a contradiction permutation choice. We are going to apply some contradiction permutation choice where it is going to do the interchanging. It is not going to interchange the data. It is going to change the place of the data from one to, for example, the first place data whatever we have in the data position 1, the data is going to be placed in third place, and third data is going to be placed in some other place. Likewise, all the 64 bits data is going to be interchanged its position without altering the data. So we are just going to interchange the position of the data and not the data. Okay, that is what. And last, whatever we are applying that key, with that key we will be taking it the result to the next sort of the round, that is round 2. Likewise, we will go for 15 rounds. So when you take the key length, the DES is going to take the key length as 56. Initially it takes 64 bits of key, and it has been go for a commutative choice, first commutative choice, that will go give you the result as 56 bits, and that 56 bits is been again go for left circulation as well as a commutative choice 2. The final key for the decryption algorithm would be like in a 48 bits key. See, the 64 bits was reduced to 56 bits after the 8 bits were being used for the parity checks. So if in case any detection, any error occurs, that is being detected by using the remaining 8 bits of the data. And the next one, that is the symmetric encryption. The symmetric encryption is nothing but we are going to use the same set of key for the both encryption as well as the decryption. So the base of this structured concept is we call it a facial network. We call it a facial network. This based on the facial network, that is whatever the algorithm previously we have discussed, that is data encryption standard, it was purely works on the basis of your facial networks, and which is symmetric structure, and it is used for the block cipher. And maximum, mostly the facial structure is one of the algorithm which is used for your encryption process, and the same thing we are using that network model into your data encryption standard. The facial networks is involved in the multiple rounds for the processing, and like round 1 to round 15, and the DES performs 16 rounds. So round 0 to round 16. Okay, so totally it is going for the several number of rounds. Okay, that is from round 0 to round 15, totally going to work for 16 rounds. And the next one is the overview of the DES operation. The overview of the DES operation is, so what are the things as I told you, one is the initial computation choices, that is IP, and the case schedule, that is we are going to allocate the key size, and the number of rounds what we are going to do is, that is we are going to take the data into 2 half, that is 32 bits, and that is going to be do for the exact process what we are going to see there is, one is the expansion process, and then the next one is key mixing. The key is going to be mixed in between the data, and the substitution technique is going to be applied, and the permutation choice has been like either in the case of initial level in the case of data as well as in the case of your key process. And the last one is we are going to go for the swapping with the help of the XOR operations. And the final one is we will be receiving, we call it as a final permutation choice, and the last we will be getting as a result, that is what the exact your ciphertext. Okay, and the DES algorithm structure is, we have an input. The input size could be 64 bits of plain text, and your key size could be 56. From that we will be taking only 48 bits of the data, and the number of rounds it is going to perform is 16 rounds, and the output of your algorithm could be your 64 bits ciphertext. And what is the strength we have in the case of DES is the efficiency as well as the widespread adoption and the security. In the case of efficiency, the DES is one is relatively fast and efficient on the hardware as well as the software process. Okay, and the next one, in the case of the federated, what is that is widespread adoption is, it is a federated standard as we have given by NIST, and it has become widely adopted in the various communication strategies as well as the application. and it was the security in the case of during the period 1970s to 1980s. When the DES was created, it was provided a strong level of security, and it in the year mid of the year 1990s, it has attacks against the DES, and such as what kind of attack has been done in the case of DES is the brute force attacks. So with this, I conclude my session. We will see the remaining topic in the next classes. Thank you.